It is test correction time, and for this mid-unit assessment, which we did mostly well on, but there are some errors that were made. So let's correct everything to make sure that we are getting hundreds on these things, and we're prepared for the regents, yeah? All right, so this diagram is a straight edge compass construction, blah, 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 blah. Select all. See how this is highlighted right here? Beautifully highlighted. All, that means there's more than one answer. So select all that is true. There's some things that you should just know at this point about a circle. And obviously there's two circles here. So in a circle, let's draw, let's just trace the circles in two different colors, right? La 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 la. There we go. Okay. So now we have the orange circle and the red circle, right? So if you look at the a circle in general, this is just a circle, that's not a circle. Every circle has two components called a radius, which is the center to the edge of the circle, or it has a diameter, which is just double that length. So it'd be this purple line, but it goes right through that center, right? So there's a diameter and a radius. What's true is that for radii, for radiuses, no matter where I draw that radius, it's from the center to the edge of the circle, it's going to be the same no matter what direction you go. So from here to there, that's also a radius. That's the same length as this, which is the same length as this, which is the same length as this. No matter where you connect it, it's going to be the same length. Because of the definition of the circle, we'll get into the next couple questions, but it's literally an infinite set of points that are same distance from the center. So let's just highlight our radii, right? Let's just do that. Maybe that's helpful for us to see. So if we're looking at the red circle, here's the center, and then that's a radius, right? And then this is a radius too. They're both touching from the center to the edge. But if you look at BC right here, this is a radius of the yellow circle, right? If we're looking at, well, let's do this in green. But if we look at this, the yellow circle goes from the center outside here, right? And then from the center outside here. Those are both radii of the yellow circle if we ignore that the red circle even exists. Want to prove it? Sure. Let's do that. Let's take this out. Look, isn't that not a radius? Right? Let's put that back in. And then, is this not a radius? Right? So, we got some radii up in here. What do we know about radius? They're all equal. So let's see what these choices are telling us. They're saying segment AB and AD have the same length. Well, AB is from here to here, and AD is from here to here. So neither of those are radii, so we cannot confirm their distances at all. That is not true. AC and AD have the same length, or number 2. So AC from here to here, and AD. There we go. So one is a radii and one is not. That is not true. So the next one, AC and CD have the same length. AC and CD right here. Yes, they have the same length because those are both radii. That's the one we're talking about. So this is one of our answers. Triangle BCE is isosceles. So B to C to E. This triangle right here is isosceles. Is that true? Well, what is an isosceles triangle, you ask? It's a triangle that has at least two congruent sides. So here's a triangle. That's not the triangle I wanted. It doesn't look isosceles at all. That one does. So this and this have the same length. That's true here, right? Look at this green line that I drew. And look at this green line. They're the same. They're both radii of that yellow circle. So that is absolutely true. And the last one says triangle CDE, this one right here, is isosceles. Well, no, it has this small red one and it has this big green one, and we don't have no idea what size this is. So no, that we can't say that for sure. So yeah, this is not our answer either. So our answers are C and D for number 1. All right. Number 2, as I mentioned in class, this is not relevant to this picture at all, even though you see all those letters. This is its own kind of diagram. So I would draw it. So it says line CD. Here's a line, CD. CD. This line is the perpendicular bisector of a line segment called AB. So where would that be? I don't know. Just draw it here. So this is A and B. So this, let's call it a green line. This green line is the bisector. That means it cut this AB into two congruent parts, and this is perpendicular, right? It's a perpendicular bisector. So The next piece says the lines intersect at point E. This is the intersection point, the only point they're intersecting at, and we'll call that E, right? So, which of these statements is true? Is E closer to A? No, because this distance is not different from this distance. That would make B also not true, because it's not closer to B either. It is the same distance, right? All these points are the same distance from A and B, whether that E was here, 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 right? It wouldn't matter because a perpendicular bisector has the same distance from point A and B, the lines you're bisecting in the first place, right? The definition of a bisector is to cut in half, so it must be the same distance from both. And obviously there's not enough information, it's not the answer. All right. Number 3. Okay, so she followed these instructions to make an equilateral triangle. So let me go ahead and draw a line right over here. My multiple choice comes from these options. I'm just going to follow these steps. So she drew 2 points, A and B. Check. She drew a circle around centered at A with a radius AB. Actually, I should have labeled that AB, huh? A, B. All right. And this radius has to be AB, so let's make this a little bigger. Sure. That looks like it has about a radius AB, right? Actually, we could have just moved this closer. There we go. That I don't have a compass here, so work with me. And then she drew a centered, another one around B, same as A, so I'm just going to copy and paste that. Here's my other circle. There we go. And then she labeled the intersection points of right here and here. She called this C and D. And then she drew these line segments. She connected this to this, and this to this, and this to this, and that to that. So, that's the last step. Check, check, check. So now we have to say, what did she construct? Well, did she construct a figure with 2 congruent sides, but not all 4? No, because this distance is the same as this. And this is the same as this. So there are at least 2 pairs of congruent sides there. That's wrong. 4 congruent angles. Well, this is a huge angle, and this is a small angle. So already, no, that's not true. That would make this one also not true because it's talking about 4 congruent angles as well. So our only option is C, but yeah, these are all 4 congruent sides. This length is the same as the bottom length, and this length is the same as the bottom as this top length. Why? Why do you ask? How do I know that for sure? Well, once again, from number 1, we're talking about radii again, right? So if we look at just this circle right here, this purple circle has a radius of AC and a radius of AD, right? Now let's look at another, I don't know, teal. This teal circle, come on, all right, as best as I could. BD and BC, also radiuses of the circle B. But what we know about the circle A and B is based on this part right here. It said circle with a radius AB, circle with a radius AB. They both have the radius of AB, meaning both of these circles are the exact same size. All right, number 4, exactly what I mentioned before, the definition of circle, right? So here's a center point, and then here's a point, 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 point, all the way around until it gets to almost line-like, right? It becomes a line because it's infinite. And what's true about all those points is that they're the same distance from this little center point right in the center all only. He is the same space away from all of these little mini infinite points. So, definition is an infinite set of points that are same distance or equidistant from a given center point. Okay, triangles isosceles thing. Does it really matter? I'm going to be honest, not really. Because they just said Construct a perpendicular bisector of segment AB. So really, all we care about is AB. Do we care about the triangle being isosceles? Absolutely not. But here is line AB. Now, how would you construct a perpendicular bisector of this line right here? Well, you would create two circles, right? 1, 2. Let's call this AB. You would construct two circles. If you want to have them the same radius, you do radius AB. There we go. So let's just move this so that A is in the center. All right, that's about right. All right, so we drew a circle around A. Then we're going to draw a circle, similar size circle around B. So I just used my compass to draw a line around, a circle around A. Didn't change the size, drew that same circle around B. And then I get two intersection points, right? Well, all you have to do is connect those intersection points. And there you go, you have a perpendicular bisector. Do the 90-degree angle for a perpendicular, the two tick marks for bisector, because those two green lines are the same size. And if I move this figure right back onto here, oh, what am I missing? Oh, the other intersection point, that doesn't matter. There we go. Then there you go. It should look, your construction should look something like this. I mean, it's not perfect because obviously I'm not using a compass, but they do allow for human error. So as long as you have all the construction components, then you are good to go. Han followed these instructions to make the image. So it's a lot of text up there that is kind of irrelevant because all we care about is the image itself. But the idea is well, you can see the two circles, right? Well, many circles, but the first two circles, he created a perpendicular bisector. Then there was two more circles, created a perpendicular bisector. So he created a perpendicular to a perpendicular. And that's where this question comes in. We'll write a statement about each pair of lines. So some of you guys were writing some irrelevant things about circles and stuff, but we care about pair of lines. So what are my lines? Well, my lines are I, J, and G. This is line G. This is line I. All right, that's line I. And line J is this teal one here. So all we're doing is comparing those lines. So line G and I are perpendicular. All right, so that's a perpendicular right here, right? Okay, well, also line G and J are perpendicular. And then finally, so we compared these two. So now we have to compare these two lines, this and this. Well, if these two are perpendicular to G, then that means line, why did I write line? Line, there we go. Line I and J are parallel. They will never touch. They will go on forever, right? These will keep going and never intersect. And that's it. These are the three statements. 1, 2, 3. About pairs of lines. Pair meaning two lines in the statement. This one was extra credit. But for this, it's the same concept as I explained in question number 1. Explain why segments A, B, and AC have the same length. So that is this one and this one. Well, they are both radii, right? So if you look at circle A alone, there you go. And I just pulled this figure out, right? Are those two not radii of just one circle? Right? These are radii of just one circle. But then what does that mean for question number 3? Well, if you look at B, if you look at C now, let's actually, I wonder if I can do this. This might be a little messy. Well, I'm going to create circle C now. BC and BA are also radii of the green circle, right? So if these two were congruent, then these are also congruent, and all three congruent sides in a triangle makes this an equilateral triangle. So that's the classification, because all three sides are congruent. Again, these are all three similar sized circles, and all radii of similar circles are the same. So that is it. I hope this was helpful. I hope you learned something, and I hope this better prepared you to be successful on your future exams on constructions and such.